It is my immense pleasure to welcome you all to the 1 week hybrid mode, that is online as well as offline faculty development program on smart manufacturing and industry 4.0 solution, jointly organized by Electronics and ICT Academy under the patronage of MNIT Jaipur. Over the next 5 days, this program will explore the latest development techniques and trends in the field of smart manufacturing. We would like to thank all the faculty members and all the experts from the around the world to accept the invitation for this, and a special thanks to EICT Academy. Now, bringing together the researchers, faculty members, scientists, and industry professionals from across the globe, this FDP offers an excellent platform for collaboration, innovation, and growth. On this welcoming part, I would like to firstly invite Dr. Jinesh Jain, Coordinator, FDP, and Associate Professor, Department of Mechanical Engineering, MNIT Jaipur, to talk about this FDP program. Welcome, Susan.
Thank you, Manish. Good morning to everyone. It is indeed my privilege and honor to extend a very warm welcome to all of you on behalf of Malviya National Institute of Technology, Jaipur, and the Electronics and ICT Academy of MNIT Jaipur. First and foremost, I am very much thankful to our director, Professor Narayan Prasad Ji Padi, and the Chief Investigator of EICT Academy MNIT, Professor Vineet Saulaji, who has given this opportunity to conduct this FDP under the aegis of Ministry of Electronics and ICT. Now, I would also like to extend my thanks to all the participants, faculty colleagues, industry professionals, research scholars, and students for joining us in this faculty development program on smart manufacturing and industry 4.0 solutions organized under the aegis of Electronics and ICT Academy. This intensive 40 hours program has been carefully structured to provide a balanced mix of theory sessions, practical sessions, and interactive pedagogy sessions to ensure a holistic learning experience over the next 5 days. The participants will be able to gain in-depth understanding of the Industry 4.0 concepts, including IoT-enabled manufacturing, cyber-physical systems, and data-driven decision-making. Explore the digital transformation in additive manufacturing, learn about the advanced automation technologies, also participate in hands-on laboratory sessions, and engage in 2 quizzes also along with this course. The program is supported by the Ministry of Electronics and Electronics and Information Technology, Government of India, aligning with national initiatives such as Digital India, Make in India, and National Education Policy 2020, which emphasizes on continuous professional development of the faculty members as well as the students. With this faculty development program, our aim is not just to enhance the technical knowledge, but also to encourage participants to adopt a modern pedagogical techniques, enabling them to transfer this learning effectively to their classrooms also, research projects, and industrial collaborations. I am confident that this FDP will serve as a valuable platform for you to interact with experts from the academia, from the research organizations and industry, and will equip you with the skills to embrace and implement Industry 4.0 practices. With these words, I once again welcome you all and wish you all an intellectually stimulating and productive week ahead. Thank you very much.
Thank you, Jinesh sir, for your keen, insightful views about the FDP. So now, I would like to request Professor Love Bhargav sir. He is professor in Electronics and Communication Department, and presently he is discharging or holding the charge of Dean RNC to give some insightful about the RNC department of MNIT Jaipur. Professor Love Bhargav sir. Good morning, sir.
Hi everyone, and distinguished panelists, I see sir is also here with Jinesh. Good morning, sir.
Morning.
So
How are you?
Uh,
Morning.
A warm welcome to this event. As you are aware, EICT Academy is one of the important pillars which is working under aegis of research and consultancy. And the scope of it has increased in the last year itself. And we are holding courses not only in ICT but also related areas, and smart industry and industry 4.0 is very important now, looking to make in India. This is very relevant theme, and the office of the Dean RNC is very much into giving all support which is required for all these activities. MNIT is very actively involved in research and consultancy. This year itself, we have got research projects worth more than 20 crores, and we have already done consultancy worth around 11 crores. And our uh, partners in research include SER, BAR, DST, MATI, host of other agencies like ENRF has become very important component now. And also a very pleasant change has been a lot of private industries are also offering research projects now. So Ministry of Coal, Ministry of Steel. So our footprint is expanding, and I do hope this will lead to a better quality of research and exposure of students to cutting edge technologies. Thank you.
Thank you, sir.
Thank you, Love Bhargav sir, for your valuable words about the RNC department. Now, I would like to welcome Dr. Ajay Nanda sir, who is Associate Professor in Department of Electronics and Communication and Coordinator of EICT Academy. So, I would like to welcome Dr. Sir to tell about the EICT Academy, sir.
Namaste. And I congratulate Jinesh sir and Banerjee sir also for this FDP Industry 4.0, which is of utmost importance in this stage. Electronics and ICT Academy Phase 2 has started in 2023, and before to that, the Phase 1 was there from 2015 to 2022. So with this second phase, the Ministry of Electronics and IT, MNIT, has given privilege to IITs, NITs, IIITs, and CDAC and NELIT all over the country to organize such faculty development program for the various faculty members all across the country. The objective is to train large number of faculty members to the cutting edge of research so that the knowledge can be effectively transferred to the students and the students can become more employable. This is one of such course which can able to give an emphasis on both academy as well as industry expertise. I have seen the brochure that various eminent persons in this particular field from various IITs, including IIT Bombay and other experts from foreign university of UK, they are delivering this particular course content. So it will be an very important platform for all attendees to sincerely attend these lectures and get benefited out of this particular faculty development program. They have to appear for 2 quizzes, which will be also helpful for them to recollect their knowledge and for the certification. So I wish everybody a very fruitful learning on this particular platform. Thank you, sir. Namaste.
Thank you, Dr. Nanda sir, for your valuable insight about the EICT Academy. Now, I would like to call Professor M.K. Banerjee sir for to telling about the smart manufacturing. That is the main theme of the course. As Dr. Banerjee has, Professor Banerjee sir has served to many government organizations and has worked as a still chair professor at MNIT Jaipur, and he is working as associate editor in GMAP Journal. So over to you, sir. So welcome to you, sir.
Thank you very much. Professor Rao Arnab, Dean of RNC of MNIT Jaipur, Professor Nanda, and then Professor Jinesh, Professor Yaswan, my dear student friends, and all other participants who are there online. At the outset, I will record my sincere thanks to the organizer. Specifically, thanks are due to Professor Sahula, whose leadership has enabled a large number of stalwarts from within India as well as outside India to participate in these innovative programs. So I'm quite fortunate that I am also able to participate in such a very important topic in the field of manufacturing. And then with the advent of the digital technology and then the advancement, tremendous advancement at a very fast rate, it is no denying that everywhere in all facets of industrial or otherwise any kind of activities, the digital transformation has taken place in a big way. So industries, the hardcore industries are no exception to that. And that is the reason why we talk about the smart manufacturing as well as Industry 4.0. So therefore, we will see that there is an integrated and collaborative activity with the digital technology, the machines as well as digital technologies. They are interfacing, they are integrated, they are collaborating, and they're giving rise to some kind of manufacturing business, which will simply go on adding the highest quality of the product, the predictive properties, and then the confirmation or the, I would say that conforming to the determinism a little more. I mean, although we are in a domain of total indeterminism, but no point in that with the advancement in AI ML, we are capable of predicting something which are reachable with precise accuracy. So therefore, I would say that the topic is quite important at this particular context. I would also suggest Professor Jinesh Jain to move to the Department of Mechanical Engineering so that the classical manufacturing courses are now transformed to the smart manufacturing, because the manufacturing these days are really made as a mass smart manufacturing. So therefore, this is the time to modify ourselves and to ingrain that kind of outlook that whenever we mean manufacturing, we mean smart manufacturing, which is integrated with all advanced digital technology. So while there will be large number of experts, much more expertise than myself, I will also learn a lot from this particular course. And I would specifically thank to the organizer for giving me the opportunity to be present in this August gathering, before this August gathering. Thank you all.
Thank you, Venerable sir, for your valuable and very insightful words. So now we are on the age of ending of the inaugural session. So I would like to call Dr. Yashwant Kohli sir to give the vote of thanks. He is coordinator of this faculty development program and assistant professor in Department of Mechanical Engineering. Over to you, sir.
Yeah, respected dignitaries, esteemed speakers, faculty colleagues, and dear participants. Good morning. It's a privilege to deliver the vote of thanks on behalf of the organizing team at the conclusion of this inaugural session of this FDP on smart manufacturing and Industry 4.0 solutions. We are deeply grateful to Professor N.P. Padi, sir, Director MNIT, for his constant support. Our sincere gratitude to Professor Vineet Savula, sir, Chief Investigator of EICT Academy, for his continued mentorship in making this initiative possible. Special thanks to Professor Nanda, Professor Lav Bhargava, sir, Professor T.C. Gupta, sir, HOD Engineering, for his steady encouragement throughout. To our speakers and resource persons from across India and beyond, thank you for joining us. We look forward to learning from your experience and insights. To our participants, your enthusiasm brings this program to life with over 80 registration across the country. Your energy, ideas, and curiosity make this a truly meaningful gathering. As we begin the technical session, I encourage everyone to engage fully, ask, share, connect. Let this be more than a program. Let it be a spark for collaboration and discovery. Thank you once again and wishing you a fulfilling and inspiring week ahead. Thank you.
With this, thank you everyone. Thank you, sir. Thanks a lot for your valuable words. So we are going to start the session shortly within 5 minutes. Thank you everyone for joining us. Thank you.
Thank you all.
अच्छा उससे जाए एक बार
तुम लोग बोलोगे तो बोल लेंगे हाँ परिचित क्या
वहीं बैठना
आवाज
आवाज आवाज
बोतल उधर डालो पीछे।
देखना आवाज आ रही है? आवाज आ रही है ना? बोलो गुड मॉर्निंग। गुड मॉर्निंग एवरीवन। आ रही है ना आवाज? That's fine. So good morning everyone. So we are on the starting of the lectures. So first lecture that we are going to start about the introduction of the smart manufacturing, which is going to be delivered by Professor M.K. Banerjee sir. He has served to the many government organization and has worked as a steel chair professor at MNIT Jaipur. Currently, he is working as associate editor in JIT Journal. So we are very thankful and over to you, sir, for giving this particular lecture.
Good morning to all the participants. As told by Mr. Manish, we will be discussing on the, little bit of introduction to the smart manufacturing, which is also what we normally say is the future of industry. And then there has been, as I told you, that there has been a sea change in the manufacturing paradigm and the area of manufacturing. So naturally, a lot of digital transformation has taken place, and that essentially constitute what is known as smart manufacturing. Now, if we look at the history of the industrial evolution, I mean, you will see that initially Industry 1.0 that invoked the mechanization where the steam power machines were invoked. Previous to that, it was the agrarian economy, and then the human, the animal power used to be employed. But afterwards, when the industry took its structured shape, then the industry 1.0 that invoked the mechanization, there's a steam power, machines, and all those things. And then you will see that there was a need for increasing the production. So for the mass production, then and for the assembly line, like say in a vehicle industry or the automobile industries, you will see that there are a lot of your electricity usage came into being, and naturally the use of electricity, use of assembly line, all those things came into being, and then they constitute the industry 2.0. Then afterwards, there has been some kind of overall changes in industry 3.0, and there the automation came into being. The PLCs, the CNCs, the IT systems, they were they took place in the basic manufacturing processes, and then the automation was a need of the industries, and naturally that is known as 3.0. And that industry 4.0 is something different. That here we find that the cyber physical integration is there, AI/ML is used, and the IoT and the robotics, all these digital technologies are integrated together to have some kind of collaborative manufacturing such that the manufacturing as such becomes smarter and it can constitute a smart industries. So, but what we foresee from here is the way that the digital technologies are improving, the way hardware systems are improving, the way the demands are changing, and naturally the question what we can foresee is the industry 5.0, where the human machine collaboration will be taking place in a bigger way, and then the personalization and the actual the sustainable personalization will be there, and then that will be constituting the industry 5.0. So that is not very long that we will be seeing this industry 5.0. If we see that, I mean, fundamentally, why do we say that it is a smart manufacturing? Smart manufacturing term was coined by the National Institute of Standards and Technology, and it is essentially a fully integrated collaborative manufacturing, which responds in the real time. That means it responds in the real time and also to meet the changing demands and conditions in the industry. You might be knowing that all the time there will be the changing demands and there will be the product diversification, where the quality demands will be different, and then different kind of conditions can be changing within a factory, and naturally to monitor those things and to take corrective actions or the remedial actions suiting the conditions thereof. So that is precisely what the smart manufacturing is able to do. So that means what is to be done there. That means it has to grab the real-time data and the data-driven technology it has to employ. Then only this can be accomplished. And how does it get the data? It collects the data from the machines and sensors and optimize the production. By optimizing, it attempts to improve the quality and keep the equipment running smoothly. So therefore, you will see that it is not totally devoid of human activity or human creativity, because human creativity, without that, you can't really think of any other technology, including your so-called AI/ML technology. So therefore, you will see that the human creativity is combined with the digitally connected machines and assets. And then the AI power. I'll tell you that what exactly is being done. The data is collected from the machines. So once, I mean, if we try to realize, then we will see that it is a digitized, well-connected and adaptive manufacturing. Adaptive manufacturing means that it learns from its experience, the just previous experience it learns, and then there are similar kind of activities. It's not a very new thing. Conceptually, it's not very new. The adaptive manufacturing, because this adaptive control system has been introduced, I mean, quite a long time since now. So therefore, the same thing has been now replicated in the entire manufacturing sector. So we call it an adaptive manufacturing. So the features will be, what were the features of this adaptive manufacturing or vis-a-vis the smart manufacturing? Here the real-time data acquisition will be there. So naturally, who will collect the data? The machines and the sensors thereof. The physical and digital integrations are there. And then from there, the data will be collected. And then they have to be integrated with the AI/ML driven decision-making system. So therefore, the huge amount of data will be, I mean, ultimately will be handled by the AI/ML techniques. And then it can ultimately give you the predictive analytics, or it can enable you to take decisions. And then the decisions can be based on the self-optimizing system. You can leave the entire thing to be decided by the system as such, instead of human going to intervene in the implementation of the decision. The implementation of the decision can be made by the system as such. So naturally, that will be basically what we say that the autonomous manufacturing. So that is essentially the autonomous manufacturing. It's not the automation. It's not the automated manufacturing, which is dependent on the use of robotics for the enhancement of the productivity of the repetitive items. But it's not exactly like this. And then the focus will be, engineers' focus shall be the control systems, the sensors and optimizations. So this will be the thing. So I have already told you that the real-time data has to be used that has to be integrated with the advanced digital technologies. So therefore, we can say that it is a data-driven approach for the optimization of optimization of the production, optimization of the process, improvement in the qualities, and predict the disruptions. So any predictive analysis can be done, and naturally this is one thing. Then what happens is that the huge amount of data, huge amount of data is being produced, and then within a period of time, the data repository will be composed of a large number of data, and then such big data has to be analyzed, and for that the AI ML technique is quite suitable for that. So whenever they get the data from the sensors and the machines, then the AI ML can identify the pattern of variation, if any disruption is there, if any deviation is there, quality deviation is there, the pattern recognition can be very easily done by these techniques. And then once that is there, then what has to be the ultimate corrective actions that can also be given by the adaptive system, and then accordingly it is also attached. In the Internet of Things will be very much usable, the industrial Internet of Things, which will also have that kind of actuator. So it will also have, through the control system, it will also actuate the newer paradigm, what is to be done for the corrective actions. So the decisions, the intelligent decisions can also be made. Intelligent decisions can also be made. You can have that kind of algorithm you can create, and then by that you can even train the entire system, including the robots. You can train the systems for the various tasks. So it's most important that industrial Internet of Things, that what do we really mean by industrial Internet of Things? These are nothing but the connected sensors, devices and machines. What do they do? They collect the real-time data from the factory floor and the supply chain, and the continuous flow of information is possible because the continuous activity is going on, and then the sensors will sense the thing, and then the devices will be there, the machines, they are already having those sensors, they are integrated with the sensors, so the real-time data will be collected, and then this real-time data from the factory floor will ultimately be processed. So how will they be processed? Now, for that, we have to once again invoke the cloud computing. And the cloud computer sometimes, to minimize the latency, so we have to have a system of cloud computing and edge computing. So cloud computing and edge computing, what will be doing that? The data will be sent to the server, and then from there it can, because the data is huge data, and then it will be sent there for the storage of data, and then for the processing and analyzing the massive data sets, which is normally generated by the smart manufacturing system. So every point the data is generated, and then we process it by the technique, the important technique, the digital twins. That is another important component of the smart manufacturing. What is that digital twins? That here the various replicas of physical objects, machines, and the entire factories can be there. That basically it's a virtual replica. The data are collected and then ultimately monitored. It's a kind of simulation, you can say. It's a kind of simulation which the entire industry is simulated. virtually an entire industry is simulated, and accordingly, it can be able to see that what is going to be the outcome of that. The predictive maintenance can be very easily possible with this kind of application of digital twins. So if I now try to understand, then I'll see that the smart manufacturing will offer the increased efficiency and productivity. It will also enhance, it will also give us the enhanced agility and adaptability, because adaptability means that you can really adapt to the newer situation by virtue of knowing what is going to be the change and having had the capability of modifying the system as such to match that newer position or newer condition. So that is what is called the adaptability. And then this kind of thing we can acquire. Then because of that, by default, the product quality will be improved. And then because the real-time monitoring is possible and AI-based analysis is possible, so better supply chain management can also be there. And also, you can customize your products. You can customize your products, and the need-based customization is possible. And as I said, that the predictive maintenance is also possible because you have the data, the real-life data. Now, so as not to be confused with the progress of the smart manufacturing system, we are basically hankering after the autonomous manufacturing. That means the autonomy means that the thing is, nobody is going to put hands onto the system. The system as such is autonomous. And now, whenever we talk about the automated manufacturing, it's not a new Industry 3.0. At that time, the automation was important. And then the automated manufacturing refers to the use of robots, massive use of robots. So robotic devices which are already programmed to serve the purpose of performing the specific repetitive task. So therefore, if I want to screw, then the robot is trained to screw, and then it will go on doing the screw, and then it will take the screw from the storage, inventory storage, and then it will put it there, and it will go on fitting the screws. So this is a kind of thing, this is automation. And then automation is essentially to enhance the speed of manufacturing and the accuracy and the high volume manufacturing. So these are the things for which the automation has been there. But what is autonomous? Autonomous is something, some manufacturing system with a brain. That means you have added brain to the manufacturing system. So the manufacturing system is learning from the data which the devices and the other things are collecting, and then the feeding those data to a cloud, and from there the data is analyzed. Intelligent analysis is possible by the AI system, and then after that the machine learning, the learning is possible, and once it learns a pattern, it knows what is going to be the trend of it. If any correction is needed, that is also that kind of predictive analytics is also possible. And then from the predictive analytics, you can go for a prescriptive analytics. That means you can say that this is what can be done. And then because of this AI, you can go on refining the AI/ML algorithms. And then once you do that kind of thing, if you apply those things in the data sets, then automatically the things will be correct. So therefore, you see that the manufacturing system as such is doing these things. Now, whenever let us try to visualize the thing, that the magnet ring, that whenever that kind of thing is there, that is already there, that is also already flying in the streets of United States, some of the streets of the big cities in United States. Google has already released that kind of. So this is not far. Or the crewless flying. So these are the possible things. How do they do that? So they always learn from the environmental data that what is to be done, and then that kind of training is already given. So the system as such does this kind of thing. So that is what is called the autonomous manufacturing. That means I mean, I am not going to make the corrections. The system as such is correcting itself by learning. So that is the learning system is accomplished by the AI/ML system and intelligent learning. And then the actuator is there with that kind of thing. The prescriptive analysis, the prescription is available, and then in accordance with that, the actuator will actuate. So this is how the actions are made repeat. So we can now see that after having this kind of discussion, we can now see that the smart factory, any smart factory or any smart manufacturing system will always have some kind of layers. The first layer is the sensing layer. Here, the sensors will be the IoT sensors, RFID sensors, the vision systems. These are the things. And then RFID system, I mean, I will tell you that where exactly they are used. So once this is there, the vision systems are also very important. That the AI vision is nowadays very important technique for the process parameter optimization. The large number of images are taken, and then from that image processing, you can get the system, and then you feed it to the deep learning you can use, or you can use CNN, the convolutional neural network, and from there you can learn the things. And once you can learn the things, then you can really, and I mean the process optimization, you can really do that kind of thing. So the AI vision enabled system is a very good system for it's getting popularized, for getting process control. And then the next layer will be the network layer. That means that the network layer means that the communication has to be there. So the 5G communication can be there, Wi-Fi 6 can be there, OPC, UA, internet connectivity can be there. So that is how they can communicate within them. The machines can communicate within them, or for that matter with the computer which will process the data. The third layer will be the data layer, where the cloud and edge computing are to be done. And then there will be the application layer, where the AI/ML, predictive maintenance, digital twins will be there. And then finally, there will be the user layer. User layers are the engineers, operators, or the managers. So therefore, you see that any smart factory architecture will be comprised of this. Now, this is a typical picture of, you can have a number of such pictures, basically that says that you can see that the smart factory is there, and then you can see that there are many components, whatever I have told you, everything is there, you can see. And then the last one is a operator, which is operating the entire system. From a mobile, one can do, from a laptop, one can do. The entire factory can be operated remote. The factory can be operated remote. It's not really required. So that's why the cloud system is used. It can be operated remote. So what are the enabling technologies of smart manufacturing? First of all, industrial IoT system has to be there, and it has to have the connectivity. And then robots and cobots. These are the things which will make the system autonomous. So the robotics and the cobots are very important for making the system autonomous. So the collaborative robots, that is the cobots, AI/ML, that will analyze the defect detection, defect identification. That is, the defect identification is from your computer vision technology. That is the AI-enabled vision technology, computer vision. So that can ultimately analyze the defects. It can actually previously the defect diagnosis would have been possible by simple image analysis technique. But these days, this image analysis has now integrated with the AI algorithm. So by that, one can do that thing, and even it can be made adapt. Can be made, because if it's a changing, it has to be understood that in industrial situation, because of the changes in the quality of the incoming input, and there ought to be some changes in the out, the machine wear and tear can also be there. So therefore, you have to have each and every point you have to collect the data, and once you can collect the data, then you can track, you can monitor, and once you can monitor everything, then you can know what is going to be the right or what is going to be the wrong. When anything is wrong, then also your system, the AI system will tell you this is the wrong because, and the corrective steps will also be told by the system. So that is why you will see that the before manufacturing, I told you that the digital twins, the your simulation is the one which ultimately gives you the entire simulation of the process before manufacturing, so that can ultimately be your digital twins. So this is one thing, and then the cloud and edge computing, they will be having the distributed computing, and the edge computing will minimize the latency, and the cloud computing will give you a huge amount of data handling capability. So therefore, that's why the cloud and edge, they are integrated together, because of the fact that we want to faster, we want to minimize the latency, and then also we can make it economical, because by edge computing, something is handled beforehand, and also we send the low volume data to the cloud to be handled. So therefore, by cost reduction is also possible. Now, how do we find the data to flow in the smart manufacturing? First of all, data has to be collected. Who collects the data? The sensors. The machines are integrated with the sensors. So the sensors will collect the data, or RFID technology, radio frequency identification that can be there. And then the logs can be there. That can also be there. The data collections can be there. And then the data has to be transmitted. The data has to be transmitted through some kind of network system. And then you see that Ethernet, 5G, MQTT. So this is how the data can be transmitted. Then the data transmission was collected. Then the data is transmitted, and it has to be stored somewhere. So the stored means that the cloud server or the edge server, the data is stored. And then once the stored data is stored, then it has to be analyzed. So data, what will you do with the data? We have to analyze, we have to diagnose the things, and then once we analyze, then we have to act on that. So automated adjustment, how do we do? Unless it is interfaced or it is already integrated with some actuation system. So it is also having such kind of actuation system, and then the cyber physical integration, whenever we'll be discussing, then I'll be showing you that how can it actuate also. So what are the benefits? What are the engineering benefits? The engineering benefits are plenty. So first of all, the real-time monitoring is possible, which will always improve or enhance the efficiency of the process. So that means any manufacturing system will always have some kind of question of efficiency. So therefore, the real-time monitoring is very, very important. If we know that at each step of a manufacturing activity, if we know that what is happening, then quite obviously, I know that what is to be done, what is going to be the next step of mine. So physically, we used to know that kind of thing. Previously, say few years back, we used to know this thing. But nowadays, human intervention is minimized. We need not do anything, because machine will ultimately see what it is doing, and ultimately it will take any corrective action if it is at all required. How does it do that kind of thing? The seeing, doing, acting, everything is done by the digital technology. So that is why the system is called the smart system. So naturally, it is a smart manufacturing. And then it can also go for predictive maintenance. How? Predictive maintenance is possible. Suppose a machine is working something, and then a CNC machine is something is giving you some kind of product. And then the product quality monitoring you can do. And then if you find that by the same process monitoring you are doing, product monitoring you are doing, I said, if you find that the process monitoring there is not much deviation, no deviation as such, and that the product gradually product deviation is there. So you will see that the performance of machine, you can also observe that kind of thing. You can also observe by the AR technique. You can also observe that kind of thing. So by the augmented reality, you can see that kind of thing. That also I will introduce a little bit, the augmented reality. And then by that, you can see that kind of thing. Once you see that kind of thing, then you know that the machine is gradually going performing wrong. So that is a usual thing that for anything any kind of hardware system you can always see that it can happen. So therefore you can go and you can also predict because you have got that analysis, the predictive analytics, you can do that kind of thing because that data is with you. So you can also say that this is why exactly the predictive maintenance will be required. I'll give you in some kind of thing when the soft computing lecture I'll be giving you. I will say that how can one integrate the predictive maintenance and in a different manner also it can be done. And then the quality assurance. Quality assurance because the computer vision aided, the AI vision aided defect detection is very much possible. And if that is made dynamic, that means online defect detection, and then the remedial measures is also incorporated. That learning system is also incorporated. Then quite obviously the quality assurance you can give because you know that this is the kind of defect which is going, and because of these the defects are there, and naturally you can take the corrective actions. So the defect detection as well as the defect remediation is possible. By that you can improve the quality assurance. That means you can improve the quality and automatically you get this thing. And similar is the case with the energy optimization, the smart usage of energy, because you know that what is the amount of energy you are spending. So once you do all these things, if you can use if you can avoid the downtime of the machines, and if you can have the quality, that means quite obviously you don't need to spend a lot of energy. You don't need to spend a lot of energy, and quite obviously you will be able to optimize the energy spending of energy. And the faster prototyping is also one of the benefits because you can do the digital twinning, the simulation, as well as on the basis of that simulated thing, you can integrate it with any 3D printing machine. So therefore, the 3D printing can also be there. By the 3D printing, you can also go for the lean manufacturing. And once you go for the lean manufacturing, you can eliminate the rejects or the material removal amount of material which has to be removed. So that kind of thing, the precision manufacturing, once you can do that, then quite obviously the amount of material wastage will be minimized, and quite obviously that will an energy benefit as well as the profitability, the economical benefit will be there. But said all these things, that there are certain kind of challenges and illustrations. The challenges are there. What are the challenges? Now, whenever we are using so many things, the cyber security threats will be there, that we do not know that what is going to happen, because of industries, whenever any industry, huge competition is there. So therefore, the competitive industries, they have got their own privacy, the process. So therefore, the entire process privacy has to be maintained. And for that, a lot of when that cyberspace is used for the transaction of data, then quite obviously there is a chance that different mechanism of data handling is there in a cyberspace. So quite obviously, malwares can be there, infringement can be there. So something can be made so as to infringe the privacy of a particular system. So those threats are always there. So you have to be very, very careful in that. Then the legacy system integration. Legacy system integration is another important thing. There's a little bit philosophical is there that once that if something is being produced in a system or some activity is going on in a system or in a society, everywhere you see that a legacy system is established. And then this legacy system, you cannot really jump from one particular. You see that even if you look at the evolution of human civilization, or if you look at the evolution of human from the lower level animals, so you will see that there is a legacy system maintenance. That means there has not been a very huge distant genetic jumps. So the distant genetic jumps was also not there because of the fact that the sustenance will be difficult. Because of that, suppose I tell you that suppose one high school is there, and then all of a sudden you say that high school system will be, I mean, some MIT system. The MIT system or some kind of IIT system is immediately introduced or retrofitted in a school. Then you will see that there will be a massive failure of the schooling system. So the school cannot really take that thing because of that. So because the legacy system has to be integrated. So therefore, whatever newness you are incorporating, it must not totally disregard the prevailing legacy. So this is important that whenever we have been introduced, you see that initially we introduced the energy, the electricity. If you look at the evolution, you will see that every time the legacy was recognized, legacy was given due honor. So the existing legacy and a new legacy was created, new legacy was formulated, and that used to be continued for some time and gradually. So whatever changes are to be made in the legacy system, that changes has to be sustainable. That has to be made sustainable by the system. So many things cannot be done at a time. Just you cannot climb the top of a tree from the ground in a single step. So basically everywhere you have to sustain your activity. So that's why the legacy system integration is very important. Otherwise, the system will not accept it. The system will automatically reject this thing. So that is what is implicated in the legacy system integration. Then your high implementation cost. Right at this moment, the implementation cost will be pretty high because the entire system, the maintenance of the digital system, and the integration of the digital system. So everything to maintain those things is a very costly deal. And then, so therefore, the implementation cost will be there. But once the implementation is done, the expenditure of the cost, then ultimate benefit will be yours. Because you know that gradually the cost of production will decrease, the cost of the amount of energy consumption will decrease. So by that, he will ultimately make up the cost, and then ultimately you will enter into the profitability scene. So, and the other important challenge is the workforce skill gap. So immediate, the engineer, suppose a mechanical engineer, most of you should be the mechanical engineer if it is otherwise it's something else. So the engineers must have to have the hybrid skills. That means because the system is not a classical manufacturing which we used to understand some 25 years back. So now the manufacturing means a smart manufacturing where the total manufacturing system is highly integrated with the digital techniques. The machines are highly integrated with the digital technologies. So once we know this thing, then we have to understand the engineers must have to have the hybrid skills. They have to know that today, of course, we are fortunate that our engineering students are very, very intelligent. I mean, it is a legacy that the engineering students are very, very intelligent. So they always learn the new things. So you will find that amongst you, many of the, most of you are quite familiar with the latest technologies of AI, ML, and then other things. It's not really needed to be a computer scientist or computer engineer, they will advance the topics. But whatever they have done for using those things, the engineers, the mechanical engineers, civil engineers, materials engineers, they should be capable of having that skill to make use of this kind of technology, the digital technology. So once that is there, so that's the reason why I say that workforce skill gap is a very, very interesting, a very, very important thing. That is a very important challenge, but it is a surmountable challenge so far as our country's human resources is concerned. But it is a general thing that that is you cannot really refute the argument that you have to have that hybrid skills. But the point is that we are quite fortunate that our engineers are quite skilled in all these things. So therefore, may not be that essentially that true, but it should not be taken as a very light thing. But it is to be recognized that this skill has to be there. Maybe our country is quite fortunate to have the better intelligent workforces, engineering workforces, but that is not a generic thing. So generic issue is that the skill has to be hybrid skills, and then the workforce has to acquire that hybrid skill. So that is a generic. Now the examples, I can also give you some examples. Now, 30% faster R&D could be done by the digital twins in turbines in a Siemens. That is a simulated activity can be there. And once the simulation technology is there before manufacturing or before activity starts, then automatically he will be benefiting the faster R&D, faster with the least rejects and the least trials. So naturally, once you can minimize these things, you can ultimately get into this kind of thing. Then you have the Tesla. Tesla, you know, electric vehicles are there. There's the robotics, AI in a gigafactory. So that is also there in the Tesla. The new generation cars, if you look at the Tesla cars, then you will see that a large amount of digital technologies has been integrated with the total manufacturing. And then the General Electric, that is also the predictive maintenance in aviation engines. So that is another important thing. That interestingly, in Indian example is also there in the Bharat Forge. That is a big, very big forging company. That AI-driven forging process is also already invoked. So that is important. And then other Tata companies also introducing the AI-driven processes. So therefore, the thing is not very far that the manufacturing, gradually the manufacturing sectors are becoming smarter and smarter. So smart manufacturing is a domain. And then how far we are going to make our manufacturing system smart. So that's a point. That's not a static issue. That's a dynamic issue. So therefore, it will gradually be improved. So this is all. And then the future trends, we should also tell about the future trends. We should also tell something about the future trends. So the future trends is the autonomous factories. This is the autonomous factories. I have given you some idea about the autonomous manufacturing. It's the manufacturing system extended to all other activities in a factory. If you do that kind of thing, then we will say that the autonomous manufacturing will ultimately lead into an autonomous factory. Nobody will be there. The lights out and manufacturing, everything. So starting from the start of manufacturing in the day and then finishing at the factory getting started. Everything is done by the factory itself. So that is the autonomous factory. So we can imagine, and the days will be there, that will be reached. So naturally, this is there. Then the other thing is that any decision, AI-driven decision system will be there. Because whenever we take a decision, we apply our mind, but based on our experience. So the AI-driven decision systems give you the huge amount of data-driven decision options. And then the decision is ultimately taken by the algorithm, which is created by human creativity or the human minds. So naturally, AI-driven decision systems will ultimately take a better and adaptive decision. Then the green manufacturing, net zero emission will be there. So the green manufacturing is the future trends of the manufacturing system. And then the human-centric industry, industry 5.2, I have already told you. So that is another future trend in the manufacturing sector. And then the quantum computing for optimization. Quantum computing is now in an advanced state. It is not in infancy. It has now reached an advanced stage. But for optimization processes in an industry scale operations, that is yet to be done. So we foresee that the quantum computing for optimization of industrial processes is not very far off. So this is the other thing. So to sum up, what we can do is that the smart manufacturing essentially integrates the automation, AI, IoT, industrial IoT, of course, data analytics. And the engineers are still now at the central to the implementation. So what is takeaway from all the smart manufacturing discussion? The smart manufacturing essentially will lead to a smart factory, and the smart factory is intelligent, adaptive, and a sustainable option. So this is where we are heading to. So naturally, the participants which are here, they will definitely take this challenge of meeting this requirement in the coming days. So this is up to this. We have had the introduction about the smart manufacturing. Now we will be discussing about the industrial 4.2 at a later time. Okay. So thank you all for this present introductory remark. Then to the next lecture.
Okay, participants, our next session will start in 10 minutes. So 10, 10, okay. So our next lecture will start at 10, 10, 10. Okay, stay on.